I don't know that this is always specific to fluoro. There will be some specific fluoroscopic things, but when it covers everything, I'll let you know. It's things you should think about in practice, especially with the modern equipment that we're using today. So first of all, there's a big difference between quality control and quality assurance. So quality control is a system of routine technical testing activities that you measure and control the quality of a process. A process. So in the old film screen days, processing was a process. Okay. Positioning is a process. Technique and exposure is a process. Okay. So it's individual silos, if you will, for different types of tests you could do. That's your quality control. Quality assurance is a planned system overseeing all of that, evaluating the quality of a process through evaluation and review of quality control data. Okay? So it's kind of like, it's like if you think of it like this program, these are your subjects, this is the program. Okay? So every hospital needs to have a process. This is really kind of a black box thing. So you start with your technique, okay? And that sets a generator, and the generator drives the X-ray tube, and you expose your patient. You have an image receptor. That image receptor has an image readout, displays the image, and an observer looks at this. So everything in the dotted box is basically covered, or should be covered, by a quality assurance program. And you can do specific quality control tests for all of these. Regulatory requirements. In 10 CFR Part 20, this is where it gets confusing. Everybody says, what does that have to do with X-ray? That covers, Part 20 is what? Radiation safety. Has to do with, mostly it was written originally for radioactive materials, but in California, basically adopted 10 CFR 20 for everything. So, 20.1101 radiation protection programs, each licensee. California, in NRC language, licensee means anybody that uses, possesses, or disposes of radioactive material. California said no. In California, licensee means anyone that possesses a source of radiation, ionizing radiation. So all of a sudden, X-ray got pulled into this entire thing. So every person who possesses a radiation source shall develop, document, and implement a radiation protection program commensurate with the scope and extent of licensed activities and sufficient to ensure compliance with the provisions of this part. So boom, all of a sudden we went from small radiation safety committees in hospitals to larger radiation safety committees that now brought in people from radiology, surgery, cardiology, ED, other folks. So it became a much bigger deal. If you're at your facilities, if you ever get the chance to sit in and observe a committee, do it. It's kind of an interesting experience. You'll find a full range of everything from how fast can we get this done to some really good committees out there that really take some time to look at things. Okay, for X-ray equipment, this is State of California, Title 17. X-ray equipment manufactured after 1974, Title 17 is really old, shall provide sufficient maintenance to keep the equipment in compliance with all applicable radiation protection sections of Code Federal Regulations, Title 21, Chapter 1, Subchapter D, Part 30, 10, 20, 30, 31, and 32. So even though this is old, it still applies. So any piece of X-ray equipment manufactured after this date, which means whether it was in 1975 or manufactured last year, it still applies. The person who registers that equipment, basically the owner, has a legal responsibility to maintain the equipment in compliance with all the sections of Title 21, Chapter 1, as stated here, even if it's changed. Okay? Government updates this every year, and you need to stay current. So that's where your regular routine maintenance comes in, what kind of program you have for reporting issues, how fast they can be resolved and fixed. For mammography, especially, mammography specifically has requirements in the federal regs. It says this is how long you have, if you find a problem, how long you have to actually get it fixed. If you can't get it fixed in that period of time, you close your room. Okay? That creates a real issue from a patient flow point of view. Okay, so quality control. To do quality control, you have to have procedures that you use to test and maintain the equipment. Procedures are important. Joint Commission comes through and looks at procedures. Regulators come through and look at procedures. If you're given the task of doing some of these tests, you need to look at the procedures. So, there are procedures for acceptance testing. Joint Commission requires that every piece of X-ray equipment coming into an accredited facility, hospital, has to go through an acceptance test by an approved medical radiation fit physicist. Now, when I was working, that's some of what I used to do. So you had a set group of tests you had to do. You compared that with what the manufacturer specifications had. Okay? And you either passed the equipment or you didn't. If you didn't pass the equipment, the vendor didn't get paid. So that usually meant for a special procedures room, you'd be in there for 7 to 10 days with a manufacturer engineer going through physical performance, processing performance, regulatory performance, and that's acceptance testing. That also allows you to establish a baseline of performance. So now you have something that when you test that equipment at whatever interval you do, whether it's annual, semi-annual, quarterly, or for California, some things, weekly, you have a baseline. So you can always go back and look at that and say, has there been a change? Is the change significant enough to bring service in? You have maintenance. You have two types. You have preventive, and that would be most hospitals either have an in-house engineer or they use the vendor engineer, and manufacturers specify what their preventive maintenance schedule is. And that's usually in the documentation that the federal government requires that they give to owners. Usually there's a quarterly, some equipment is semi-annual, other piece of equipment is annual. The vendor comes in and does their preventive maintenance. If you have an engineer on site in your facility, usually that engineer is the person doing these according to what the manufacturer requires. Okay. How many of you work in a facility that you know has an in-house engineer? Okay. If you ever get the chance to meet and talk to that person, you can learn a lot about any piece of equipment in that facility. So if they have a little time to kind of take you through and tell you about how equipment is installed and maintained, it's something you can stick in the back of your head, and that will help you in your future career. Unscheduled maintenance usually means something broke. And that can be anything from the light bulb in a collimator to an arcing tube, which is no fun, scary, but not particularly dangerous. Buckies that won't move, exposure switches that have a frayed cord, inability to make an exposure.
Not detending.
I'm sorry?
Not detending.
Yeah. On a digital piece of equipment, you have artifacts. That's usually enough to shut a room down. So those are unscheduled maintenance, and that's when you have to put in a service call and get that equipment fixed. Joint Commission requires that these records be kept. They will come in and pull them and make sure about frequency, how quickly the facility gets that fixed. It used to be they'd say, well, it's, we called the vendor and the vendor didn't, do it on time. Joint Commission says, we don't care. That's your issue to deal with. It's not the vendor, okay? So you have to keep on these guys. Then somebody has to go in after it's corrected and verify that it was corrected. And that usually means pulling your medical physicist back and saying, make sure that the vendor did what they're supposed to do. And then that record gets kept. Okay. Very busy slide, but basically, let me kind of consolidate this. California, for fluoroscopic equipment that has automatic exposure controls, which would be your automatic brightness system, okay, the operator shall monitor tube current and potential at least once each week to ascertain that they are in their usual ranges for a given set of operating parameters. So that could be done by setting the controls to usual settings for fluoroscoping an average patient and using a phantom of any suitable material with attenuation roughly equivalent to 9 inches of water or 7/8 inches of lucite. An appropriate aluminum, steel, or copper phantom can be used. However, only 9 inches of water or lucite 7 7/8 inches can be used for measuring fluoroscopy dose rate. Whenever the monitor tube current and kV change in such a way that results in a 25% change in patient exposure, you remeasure it, and if it still fails, then it goes in for a service call. If it has manual exposure control only, the operator shall monitor tube current potential at least once each day during use to ascertain they are within the normal ranges used by the facility. Most people say, well, we don't have manual anymore. Some of the older mini C-arms, bless you, still have a manual system that don't use automatic brightness control. So they still have to do it every day that the system's being used. Okay? You have to keep a written log, and it has to include at least tube current and potential, the date, the identification of the fluoroscope, the name of the person who did the monitoring. Records have to be kept for at least 3 years, or, it doesn't say this here, but the interpretation is 3 years, or to the next X-ray inspection. Okay?
Thank you.
So this is a California requirement. It's each week.
Yep.
And some of you may have been involved in this. Some of you may be tasked with this. It's a popular thing to have students do. At Kaiser, for the weekly check, we used a steel plate mounted on rubber so it didn't scratch anything. The baseline was obtained when the equipment was installed. So during acceptance tests, that's one of the baseline measurements you take. And then the facility is responsible for doing that every single week. The state gets really, really upset if you miss a week. They'll kind of go, yeah, 1 week. You miss 2 weeks or more, it's going to end up with a notice of violation. Where that comes into a problem is we have X-ray equipment everywhere. Radiology, urology, surgery, cardiology, pick an ology, and they all have X-ray in them. What the facility has to determine is who's going to take responsibility for that weekly check. In some facilities, the night X-ray tech gets to do it, and every night of the week, they do a certain set piece of equipment, and they just keep doing that in perpetuity. In some facilities, no. Radiology says, hey, we'll do our equipment, you have to do yours. I guarantee you that's when the facility is going to get cited, because places like urology, orthopedics, Surgery, they kind of go, that's not up to us. Somebody else can do it. So, but it is really, really important. The written log is important. State will go through and check it. Joint Commission will go through and check it. Okay. Okay. Measurements of tabletop exposure rate.
Gauge is there.
It's on the edge of the way.
There we go. No.
Up to.
Up. No.
Down, down, right there. Up, down.
Down.
It's right on.
There we go.
Bye-bye.
Thank you.
It'll go away.
It'll go away. Good. All right. I hate technologies. All right, so the tabletop exposure rate for fluoroscopic equipment has to be measured at least once a year for units with automatic exposure control and at least once every 3 years for units without automatic exposure control, and immediately following alteration or replacement of a major component such as X-ray tube, exposure controls, imaging assembly, power source, image intensifier. Okay. On cineradiography equipment, the exposure rates to which patient are normally subjected shall be determined at least once each year and immediately following, etc. verifications. When we went digital, now, let me just say, California's in the process of updating Title 17. I don't know how much you folks know about the regulatory process, but from inception, which is where you think, oh, we really need to change this, to when it actually hits the regs and is published can be as long as 3 years. Okay, it has to go through the world. So this is in the process of being updated. So the state, since this is still old language, referring to cine as in what we used to do with 35 millimeter film, which was very high doses to our patients, very high. In the digital world, they said, well, it's digital fluoro, it's all pulse, so you have to measure it in every pulse mode. And we said, no, wait. If you look at cine in the old world, cine was 30 frames per second or 60 frames per second on 35 millimeter film. So you should consider that the same definition in the digital world. So after a year of hemming and hawing and finally doing that, they issued an interpretation that says, if the piece of equipment is capable of doing 15 frames, that's not pulse mode, that's images. So 15 images per second and higher, they consider that to be cine. So that'd be equivalent to angiography and things like that. If you're just doing fluoro at so many pulses per second, that does not apply here. Okay. I want to go back to one thing. When it talks about usual settings for fluoroscoping an average patient, so for measuring dose, an average patient in California is 9 inches of water or 7 7/8 inches of lucite, and it's the largest mode that the image intensifier has. So if you're using an image intensifier that's a 14-10-6, it's in 14-inch mode. If you're using a DR fluoro, it's the largest size. Usually they're either 30 by 30 or 40 by 40. Okay. For your weekly checks, you can put anything in there that mimics. We just, like I said, we chose steel because we could come up with something that was fairly lightweight but still attenuated enough to pretty well match that. Okay. This is a SMPTE test pattern. This was developed, well, you can see this one was copyrighted in 1983. It was revised in 91. Still exists in this form. the Society of Motion Picture Technologists and Engineers came up with this. And this is a means of determining the grayscale ability of your visual system. So, I don't know what we can see here, hold on. So, yeah, I can barely see it. If you look kind of close, you should be able to see the 95 and 100%. So there's a 5% contrast distance here. Then you go 100% all the way down to 0%. And then you, in a really good system, you would see the 0.5% box in black. And and you can't see it. So what we would do in this case is say this is a non-compliant system, and we would have to go through and redo this so that you could see everything you need to see. These are, of course, bar patterns, both in high contrast, low contrast mode. This is a uniform grayscale. The grid lets you know if you have any distortion. This is a very useful, very quick test. Radiologists don't like anything extra. The way that this should best be used is every morning it should be part of the boot up of their reading computer. So the first thing they see in the morning is this, and to go on, all they have to do is look at it and say, yes, we can see everything, click a button, and then they can go. They object to that. It's unfortunate. But usually your medical physicist, whether they're in-house or they're under contract, would come through and look at these on some regular basis. In mammography, it is required under federal rules. Fluoro, it's strongly recommended. Because in the digital world we still print, there are digital printers. I think they're ultimately going to go away, but most facilities do have a digital printer for very rare needs. For example, if a patient wants a copy of their images, some facilities will put them on a disc, other facilities will actually print them out. At the time I retired, it was still an issue with the court for malpractice, whether the court would accept digital images. Excuse me, the feeling was that, well, how do we know that those are real? How do we know those haven't been manipulated? Whereas if they print it, it works. So just like we used to do sensitimetric strips on film screen, instead of running it through a processor, we would print the SMPTE pattern on a digital printer. We'd read it with a densitometer, and we would plot the measured optical density. This is an example of a SMPTE test on a printer that you can see what the density aim is. Remember, digital is linear. There is no S-shaped curve, there's no H&D curve, it is a linear plot. So the measured density is in blue, and your aim point, which is in green, and then you've got your error bars of what you allow. This is obviously a system that failed, had to be recalibrated, retested, and it came in basically right on the nose, except for slight off here and slight off here, probably only off by about 1% or 2. Okay. Half value layer is something that is technically measured only at acceptance and if you change an X-ray tube. If you change an X-ray tube or collimator, then half value layer under state regs has to be measured again. And that's just, an exposure without aluminum, and then you put increasingly thick pieces of aluminum in, and you look at the readings, you find out when they stop, go below a half. It's not really accurate. Anybody want to propose a reason why it's not exactly accurate? Half value layer was originally designed for radioactive material. A gamma emitter emits a single energy gamma. It's what we call monoenergetic, in which case half value layer is technically correct. X-ray is what?
Polyenergetic.
It's polyenergetic. So every time you put a piece of aluminum in, the resultant beam is hardened, right? So you keep adding aluminum, what comes out is a more hardened beam. It's close, okay, but we still call it half value layer. You just need to know that there are some slight technical issues with that, but it's, what's the phrase? It's close enough for government work. You have to figure out where you're going to measure it. For these three different types. For a standard RF room, like we have in the back, you put your measuring device at tabletop. It never gets right at tabletop, but you measure it here. And then guess what you have to do? It's only 2 centimeters between your chamber and the top of your table, but you still have to inverse square that back. And what's interesting is some engineers set that so close, if you inverse square 2 centimeters, you go out of compliance. Okay, so you do have to make sure you do that. For an over-table system, okay, it's 30 cm above tabletop. And for a C-arm system, it's 30 cm above the surface of the image intensifier. That's where they have to be measured. And what goes in the beam is usually 7 7/8 inches of lucite. That has to be done once a year. It's mandatory. What's interesting to think about is some hospitals rent equipment. Some hospitals bring equipment in to evaluate for purchase. Okay? And a lot of folks say, we don't have to do that because we're not going to hold on to the equipment. It's a temporary use. State of California and Joint Commission especially says, Joint Commission says every piece of radiation emitting equipment that's brought into an accredited hospital before it is ever used on a patient will go through an acceptance test. Both for image performance, equipment performance, electrical safety, all of that has to be done. Okay? That takes a lot of time. But that includes not just X-ray equipment, that includes ultrasound, CT, MR, C-arms, portable X-ray, any piece of equipment that comes in. The non-imaging equipment has to go through that with the people in the hospital that deal with the non-imaging equipment. So that'd be your laboratory equipment, blood equipment that does your blood tests and stuff. Okay. Okay. So another type of quality control test is retake rate. Again, a lot of this is coming out from mammography, because in mammography, under federal regulations, this is required. You have to have a program. For radiology, it is not recommended. It's strongly enforced by Joint Commission. Joint Commission expects you to, there's different regulatory agencies. I think in one of my lectures I talked about Joint Commission is what I call a de facto regulatory agency. They don't have any regulatory authority except for the fact that Medicare says if you do procedures in your hospital and you want to be reimbursed by Social Security, Medicare, you have to be accredited. So it's kind of a, if you want to get paid, you got to do it. If you don't want to get paid, you don't. So yeah, so you do. You can do this either by room, you can do this by procedure type, you can do it by technologist. My personal point of view is you don't do it by technologist unless you have a good staff and a good management team who work together to say, we're not going to use this as a punishment, we're going to use this as an educational exercise. So if you can do it like that, that works.